Good evening, sir.
Hello, good evening.
Am I audible, sir?
Yes, yes. Am I also audible?
Yes, sir. Yes, sir.
And am I also visible?
Yes, sir. Yes, sir. You're visible, sir.
Okay, so just I will upload my PPT, and here also I have to share ArcGIS and ADAS software interface also. So is it possible?
Video, sir.
Yeah, no. Here I have to share PPT
Okay, sir.
for my lecture. And another thing, that during their same presentation and lecture I have to show some ArcGIS and ADAS image in some softwares. So is it means
Yes,
how
sir.
to say
It,
here?
yeah, yeah. It is audible,
No,
sir.
my question, no, please,
It,
my question is that I am acquainted with Google Meet, so here I use this but not so much. So how to share the screen here? Just only that thing I want to know from your side. Yes, here share is there. Okay. uh, just sharing is not turned on. Okay.
sir, I made you as co-host, sir.
Yes, please.
I have given you as co-host, sir. So you can share the screen.
Okay. Hmm. The host is not showing. uh,
Sir, good evening, sir.
Good evening.
So myself Giridhar from Bulaya College of Engineering.
Okay, good evening, sir.
So, sir, there are some icons like participants, charts, react.
And share.
Then click on that, sir.
But actually I clicked it twice, but host has not given you permission. That was the message. Just I'm once again I'm clicking.
Yes, sir. You
The
just click it now.
Okay. Host is not allowing sharing for this meeting. That is the message.
Arnima madam, can you please give him
Sir,
co-host?
I have given him as co-host, sir. Sujit Kumar. Oh, sorry, sir.
No, you have to give it to admin. Like his
Admin.
name, admin.
My name is at present admin.
Yes, sir. Yes, sir. Yes,
Your
sir.
name is, oh, okay. Sorry, sir. I've given
No
the
problem.
wrong person, sir.
No problem. No problem. It's okay.
Sir, I've given, sir.
Okay.
Yeah, now you can. Sir.
Yes. It is there, so that now I can share my screen.
Sure, sir. Yes, sir. It's visible, sir. Sir, small thing. If you
Yes,
don't mind,
please.
after that, there is an option at the top right. Top right, there is an option. Can you click on that, sir, please?
Just 1 minute. Uh,
More. You
just
have option more, sir.
just I'm doing the same thing. Yes, sir, please. Where it
Yeah,
is?
there is an option. If you take your cursor to top,
Top.
then a small pop-up will come down. On that,
Yes. Yes.
on that extreme right, there is
Uh,
an option called more.
Actually, there is a
Right side, right side.
right side my recording, sign in, recording, YouTube view. Is it like same? The same thing you are.
No, sir. Actually, you have to take this what cursor to top.
Uh, okay.
Okay, sir. No problem. No problem, sir. I mean, to deactivate annotate.
Okay. Yes, I got more. Yes, please, sir.
Yes, sir. Then click on that. After that, disable annotates for all.
Disable annotations, another feature.
Yes, disable annotates for others.
Okay, annotation. Okay.
Done,
Yes,
sir.
कर दिया
That, thank you very much, sir.
Okay,
Okay, thank you.
Okay, now okay,
Sir,
PPT
good
visible?
evening, sir.
No, my PPT is visible.
Yes, sir, it's visible,
Okay.
sir. Sir, just 2 minutes, sir. Participants
No,
were
no, I
joining.
know, I know, I know.
Okay, sir. Welcome to day 4, our FDP, where we continue our journey. Good evening to one and all. I, Miss B. Ramya, Assistant Professor. Gives me immense pleasure to welcome you all to the day 4, session 1 of our ACTE ATAL Faculty Development Program on Sustainable Practices and Innovative Trends in Civil Engineering. A warm welcome to all our today's resource persons and participants who have joined us from different institutions across the country. We continue today with more distinguished speakers and exciting topics. We are privileged to have Professor P.G. Agnihotri sir, Professor at SVNIT Surat, to deliver a session on data acquisition and study tools using RS and GIS and exercise on watershed delineation. Before we begin, I now invite our faculty colleague Dr. Arunima Mahapatra, Associate Professor, to formally introduce our eminent speaker to the audience. Over to you, ma'am.
Thank you, ma'am. Good evening to all. Now it's my privilege to introduce our distinguished resource person for this session, data acquisition and study tools using RS and GS, an exercise on watershed delineation by Professor P.G. Agnihotri. Professor Parishit Girish Bhai Agnihotri is a professor in civil engineering at SV National Institute of Technology, SVNIT Surat. He holds BE and ME Civil Water Resources from South Gujarat University, both with first class, and a PhD Civil Engineering from SVNIT completed in 2013. With over 31 years of experience in teaching, research, consultancy, and administration, Dr. Agnihotri has served as Dean, Faculty Welfare, Associate Dean, CPIO, RTSL, and is currently Professor in Charge, Training and Placement at SVNIT. His expertise spans water resources engineering, flood mitigation and management, surveying and geospatial technologies, GIS, GPS, RS, and GS. He has supervised 7 PhD theses, 7 are ongoing, guided 34 MTech dissertation, and published extensively with 49 international journal papers, 38 international conference papers, 12 book chapters, and 14 national publications. He has also reviewed numerous papers, PhD theses, delivered 35 plus expert lectures, and handled consultancy projects worth over 50 lakhs, including collaboration with ISRO Space Application Center. Professor Agnihotri teaching portfolio covers subjects in surveying water resources, GIS, remote sensing, irrigation, and flood control. He holds a patent titled Approach Towards Water Harvesting and Recharging in Hard Rock Area, awarded at Australia 2021. He has actively contributed to several outreach and expert activities, such as serving as an expert member for the urban challenges of Surat City study, member of the flood risk management subgroup, and subject expert for various academic and research evaluation at institutes including Gujarat Technological University, SET Surat, Kadi Sarva Viswavidyalaya, and Utkar Tarsarali University. Professor Agnihotri is also a member of several professional bodies, including the Institution of Engineers, Indian Society of Technical Education, ISTE, Indian Society for Hydraulics, Association of Hydrologists of India, and Association of Hygrometeorologists. Through his extensive teaching, research, consultancy, and administrative engagements, Professor P.G. Agnihotri has made a substantial contribution to civil engineering education and water resources management in India. We are truly honored to have you with us today to share your valuable insights on the topic data acquisition and study tools using RS and GS and extensive and exercise on watershed delineation. Let's welcome Professor P.G. Agnihotri to the session. Over to you, sir.
Okay, sorry, just it was a mute mode. Thank you both the madam for giving the kind words for my introduction. Just I will start with the lecture. So, okay, so now is it presentation mode is visible?
Yes, sir, visible, sir.
Okay, only that is the thing. So here today there is a data acquisition and study tools using RS and GIS and exercise on watershed delineation. Actually, we will just little bit start with the background of geospatial technologies. Geospatial technology, so that is a word geo space, geo earth. Okay, that is a Latin word geo, and spatial that is related with space X, Y, and Z. Here for spatial, there are so many pronunciations are there. Some Bombay people, Roorkee people, some are using spatial, some using spatial, whatever it may be. Somehow I am using spatial, like immediately or immediately, or schedule or schedule, Britain and American pronunciations. So okay, that is not our business. So this is term widely used to describe the spatial software with the analytical software or any engineering software for the event which is taking place on the surface, not surface, but on the earth. And that earth, normally we are saying as a terrestrial or geographic. And that is earth means surface, inside, and atmosphere. So this technology is actually not baby of civil engineering, but all the field of engineering is required this tool. This is a tool, and this tool, geospatial technology, this tool is a very much important today's for the research work, consultancy work, professional work, and all the major project like metro project going on in our Surat city and other so many other things. So this is a basically having three tools: Geographical Information System, GIS, Global Positioning System, GPS, and Remote Sensing, RS. So just in a brief, I will give you that introduction or the role of these three tools, and then we will go for the downloading of image interpretation, how the image, some processes are there, and lastly watershed delineation. So here I will use two software. One is ADA's imaging software, one is ArcGIS software. So remote sensing is a information acquiring of information from the airborne, spaceborne equipment and there is no contact between the equipment and the object. That is using the electromagnetic radiations, different energy bands. GPS is nothing but it is the it is the instrument which operated with the connection of signals from the satellite, and it gives the precise position of a place or location, and normally it is in a mode of point, line, polygon. Okay, and most useful it is in the preparation of DEM. That is a digital elevation model. It is the digitized version of control map. GIS. So GIS is a very much what we can say the operational type, or it is a working type of a tool where number of other softwares are there. IGIS, ISRO software is there. ArcGIS is from ISRI, ESRI software, and it is done by overlay operation. It is actually there is a word is thematic layer, theme wise layer. Okay, so that's why the software, when the students are working, we are working, researchers are working, so they have to create the layer as per their object themes. How many themes are there? 5 themes, 1 theme. Okay, and like that. So this geographical information system is such a system which collects the data, capture the data, store the data, manage the data, retrieve the data. Okay, and that is also as per the user requirement. Just like you have a data, and to store or to manage the or to maintain the data, that is DBMS, it is known as database management system. And there are 5 components or 5 family members of GIS. That is a computer, software, persons, those who are working, methodology, whatever your project. If your project is related with the flood control, then it may be the hackers software and other software you to use. And the most important thing in GIS system is a database. Data collection is also very time consuming, tedious work, and the data integrity is also important. Even if there is a small mistake or in data, maybe say, let me give you the example of a GPS data or total season data of a point, their x, y coordinates and z height. So in height z, if there is some decimal is also missing, then the result, the digital model will haphazardly, it may be having something wrong, which I have observed during my research work. Okay, so this is regarding the GIS. GPS, it is nothing but it is the radio-based navigation system. It is a Navstar navigation satellite timing and ranging global positioning system, and the main its work is to give the precise position, and it works in relation, in coordination with the signals received from the satellite. And here one thing, that x, y and z is written here, that is nothing but it is when we are working in a global level, it will be latitude, longitude, and this z is the height. But this z height in our normal surveying, in our normal leveling exercise or third dimension, is normally from the mean sea level. Here it is not like that. It is a little bit different. Mean sea level is known as a geoid based, gravity based. Okay, and mean sea level, and this base or this GPS datum, that is known as spheroid base. If Earth surface, it is elliptical. If it is revolved about the major axis, an ellipsoid will be created, and that ellipsoid is a base for this. So sometimes that happened that your normal RL with mean sea level is a positive, but the GPS RL or GPS Z value may be negative. So you are above MSL but below the spheroid. Okay. And there are different types of receivers are GPS receivers are there. And here also as a civil engineer, we are just working as a driver. We are driving the new cars, new bikes, or new any other vehicle. Okay, but we have some knowledge, like say car, what is a gearless car or gear, or what is a clutch and other things. And at least you can open the lid of a petrol or diesel, or you can open that bonnet. तो इतना नॉलेज तो हमें होना चाहिए, that much knowledge. So we have to see some basic concept, basic what is the funda of these three tools and their application. Our major part is the application. And who then other people who are designing this, who are involved in this science and basic funda, that is normal electronics people, computer people, and other, even physics, basic physics is also here used in this. And remote sensing, it is the art and science of obtaining the details of object or any measurement without being in contact with it, and it is working with the signals received from the satellite. Okay, so with this we will just these are the advantages. Here I have actually not included, I will go to the directly with this our main topic, that is a download, subset, and water delineation, and even what image interpretation. So here these are the advantage of remote sensing, or you can say geospatial. It all the three are together. Okay, and without that you cannot I mean work, or your project will not be successful, or you cannot even do the work. So large area provides regional view. This is written in context of aerial photogrammetry. It is here hierarchical order is like that. First on the ground, that is our working of with our normal surveying instruments, total stations and other thing. Then we are going one step at the other, from aircraft, camera and aerial photogrammetry, stereoscopic vision and interpretation and working. And then still further is a spaceborne equipment, that is the satellite. So remote sensor sees over broader portion of the spectrum of spectrum than human eye. Here, this is the thing that is the difference. Our eye is having only the energy perceive 0.4 to 0.7 micrometer range. Electromagnetic radiation, electrical field, magnetic field. And there are other energies are there, ultraviolet, infrared, radio, microwave, radio wave, gamma waves, X-rays. Okay, these different waves are there. Normally remote sensing that are using visible zone, microwave zone and infrared zone. And in our total station also normally infrared bands, infrared energy is used. So these are the different sensors, and that this will be doing, or they are working. Here this georeference word is important because it is just the registration of the image, or the image will show when we will open in a software absolute position, let launch, because he previously GS we seen that we have to work on layer wise structure. So when there are a team of the students and they are in a they are working differently. Suppose there are your college campus is there and your college campus map is there, it is a basic input, and your three students teams are working on that. So you will give this map to all the three teams leader. One team has to just digitize the building of your campus, one team has to digitize only that roads of your campus, and one team has to digitize only the electrical light poles are coming I mean there in your campus. And when the supervisor or mentor will take all their work and he will load in his software, all three layer plus your campus basic map should overlap. So if georeference is not there, then it will not overlap. That is the meaning. Okay. Some remote sensor operate in all season, night, day and night weather, and like this. Then these are the actually these applications, but I am just reading quickly. Land LULC mapping, land use, land cover, environmental application, hydrological application, urban planning, hazardous and other thing, telecommunication. And here particularly in urban planning it is very much important, because in urban planning the planner has to give so many alternatives for the maybe regional planning, maybe city planning or another planning, and that can be very well prepared in GIS software, GIS interface, and it can be demonstrated to customer or authority. Okay. Now here we will use the word image or aerial photograph. Aerial photograph are having only that view or that portion which is visible by our human eye, and only 0.4 micrometer to 0.7 micrometer range energy can capture. Now remote sensing or this image is from the satellite, and there are number of other energy bands are also used. So that is what we have. These are the different portals, different platforms are there for image download. So that download or capture, there are normally our Indian portal is a Bhuvan portal, USGS, United States Geological Survey. Okay, that are other some we will see just SAS softwares are also there which will download the image, and here up to some resolution images are free download is there. Okay, just like this, if you have seen now in so many our medias and other platforms, OTT platforms, and if you're using something, some serials or some story, they will give only one episode and then say that is a free trial. So here in free trial means what? You can download freely for your work. What is the importance of your work? How much that is known as a resolutions of image, resolutions of DEM, even LULC you can download, even particular area soil map you can download. Okay, so that is the that depends. So how to that download? There is a free, as well as if you want to go for the micro level more detail, then you have to pay. Okay, here just for image interpretation, there is a software is ADAS image software. We will see the some exercise on this ADAS imaging also. Okay, here yes, to how to download the images. One is a USGS Earth Explorer or NASA Earth Data. Then another one, what are these are the things are the description, but these platforms, how to work means how to do the work in the platform. So that is the detailed step. So first of all, you can choose any platform. Okay, previously I'm talking about before about 20 years or like that 2005 to 2010. Then at that time only USGS Earth Explorer means that was I have downloaded and I was working with that, and my account was also there, but now it is deactivated. Then there is a Bhuvan, that is a ISRO Indian Space Research Platform. Google Earth is there. Then NASA Worldview is also there. So here these are the different platform. So what? How to go? Just the steps are there. Create an account. Some just USGS requires, Bhuvan also requires to create your account, means your authenticity, your institute, your email and other things. Then it will give you or it will display that area, particularly whatever you will give that, whether of your Andhra Pradesh or your institute or even Gujarat or Delhi, whatever it may be. So define your interest, area of interest, AOI. So for this, you have to either give by drawing tools in the same platform. You have to give the drawing tools that this much area I want, or by description you have to give that this much lateral launch to this much lateral launch is my area. Okay, that is there. Then after data and filters, so which type of image? Okay, there is a Landsat, then lease, and so many other different types are there. Now there is a what I can say, the merged image also is there. When I was working, there is the composite image of lease 3, sorry, Landsat 3 and lease 4 image, because the one satellite image has a spatial resolution better and another image has a colored image, that is its radiometric resolution is better, and then combined and merged image I have used. That type is also there, but as and when you will go inside and you will get it. Even you have to give the what is the date, what is the resolution, the criteria, and in this, as per the policy of that platform, you can go up to that level of accuracy. Then say that okay, no, if you want this much accuracy, then you have to purchase it. Then download the image. Normally the download, you can whatever the area you will give, and you can download it, and the downloaded file, that is in a rar or zip file, and that unzip file you have to unzip. But that, say just we are taking as an images, just as an images only. So I have downloaded the image of a Gujarat state, that covering that area, and in a zip folder there are number of you will find the images, okay, bunch of images. Okay, here I just got this meeting is being transcribed. So should I push? I mean, okay, sir, please. Hello.
Hello, sir.
I am. There is a message displayed. This meeting is being transcribed. So should I put okay, because exactly I don't know.
Okay, sir.
Yes,
You
sir. Okay, sir.
Okay. Thank you. So when you will zip folder you open, there are number of bunches of images. So that image, if you will open any single image, you will get very much, I mean, not blur, but black and white and something, and then it's not understandable. So all these layers, you to do one exercise of stacking in a ADAS image software, and then after your final finished image will be displayed to you or in the software interface. Okay, now here USGS Earth Explorer, that is a Landsat and other data. So just these are the step. Okay, just quickly I'm going that you open this USGS, create your account, then use search criteria tab, then area of interest, that is by zooming in or out, you can select using drawing tool. Go to data set tab, select the data you want, such as Landsat collection. Okay, even which date, which day, which type of satellites. Use additional criteria tab to filter the result by date, range, cloud cover. Okay, then go to results tab, preview the screen, click download button, and it will come to you. So that is that whatever you will be downloading, that is in a form of normally WinRAR or zip file. Same way for Indian satellite data Bhuvan. Go to Bhuvan data, login. Then there is a satellite sensor, and we have resource set 1 or list 3, that whatever is required to you. That different satellites has a different capacity, different resolutions. Choose your area of interest using methods like latitude, longitude, map or sheet number, or by drawing on the map. That is nothing but by drawing tool of this platform, you select your area, or you can give the let launch and then click download. This is for Bhuvan. Same way using SAS Planet. So download and extract the SAS Planet software. Now this and then launch the SAS Planet application. Same way here you have to go to this map imagery, zoom out, zoom in, select. Okay, even sometimes you can select also particular say a particular, say Gujarat area or Andhra Pradesh area or Delhi area. But normally during the downloading, that I have not came across to that type of work, but it will cover. And if you want, suppose say Delhi area, then Delhi and all area that will be there as a one slide or one image. Then after there is another process is there, that is a subset we will see in subsequent section of only the border of your Delhi or Surat city or Mumbai or Gujarat or whatever it may be. That is known as a subset of image. Then single image from Google Earth Pro you can have also. It is a very much simple and available Google Earth Pro, where you can even your save also, and you can put some markings also in this. Okay, so now we will just go to the, with this are the downloads available, and this is by and large, except some very much important operations or any important project for our research project study purpose, we can have the free downloads are available. Even in ArcGIS software, students edition, educational editions, which are freely available, but there are access is given very limited. Okay. So now image is nothing but, if you will see the photograph, okay, aerial photograph, same thing, that is nothing but the data collected over the regular interval or grid, and that is being displayed in a form of a picture or pictorial view. Okay, so that is a digital photograph, digital video, and that's so many different examples are there. Now when we will use the word image, normally it is a satellite image. That means it is a satellite obtained from the satellite, and it is how it is working. So it's simple, just concept is there. Either energy of sunlight incident on the surface, and it is reflected back towards the sensor put in our satellite, or some objects emit the energy of their own, and that is captured by the sensor. So when this energy is captured, written energy captured by the sensor, on the basis of brightness, it will give the number. For darker portion 0, and most, that is the most bright portion, it is 255. That is a 2 raised to 8, that is a 8-bit image. Okay, we will not be discussing that thing here. So that is the image, and that image, how it looks, what the details is contained, how much detail you can go, and so what you can sometimes, if say normal our photographs using our mobile and some group photo, what are the photo is there, and if then in our mobile screen, if we are zooming it, then after some zoom you will get some details, but after zooming it blurs. What we can say, pixels are just torn, pixels pure fat gap, image is just distorted. So that is the resolution. There are different types of resolutions are there: spatial resolution, radiometric resolution, temporal resolution. Okay, so this it is there. Here these are when the image we are considering. So apart from this, our spatial coordinates XYZ, which time, what is the sensor design, polarization, which wavelength, means which energy is there, that also we have to see, and as per our requirement we have to select the image. Okay, image interpretation, here there are two terms are there. One is a metric and another one is a interpretative. Okay, so here image interpretation. So interpretation means you have to study or you have to view the image, and you have to identify what is there. But this is not with the like this, the I have some photograph and I am viewing. No, that is of course aerial photographs, Other images, hard copy is available. We are also viewing in stereoscope, but that is becoming now obsolete. Okay, and everything is now digitized. Here, just I will tell you that what is a digitize also, what is digitization process. So you have to use any software and you see and you look into the colors, other combinations, you give your interpretation that what type of feature is there, maybe playground, maybe built up area, maybe water body, or whatever it may be. So here, this is for interpretation. Another one is a metric. Metric is nothing but we have to take the measurement, or we want to find if there is a lake, is there, what is the area of lake, perimeter of lake, if there is a tower, is there, what is the height of tower, and that is a metric type. Here normally we are doing this processing of interpretation now using computer based, using the software. Okay, so previously aerial photographs we are using in a stereo pairs, and due to overlapping we will get the 3D views, and we can interpret and we can prepare the topographic map from that. But that method has become now very much obsolete. Okay, so when we want to interpret image, okay, in the previous slides, advantage is there is a word was LULC map. So land use land cover map. If you want to prepare, so for that preparation, this image interpretation is very much required. So image interpretation means identification of an object. Okay, like this, if you will see some photographs of, say, normally sometimes what happen, some friend circle or some even some faculty group, and they will take some photographs of 2000 and say इसमें से कौन है, इसमें पहचानो कौन है, ये कौन से सर है, या तो स्टूडेंट्स का फोटोग्राफ है. So what is that? That is same thing is here, this elements of image interpretation. So that is a tone, texture, pattern, size, shape, shadow, association, and sight. So this tone related to brightness or color. Okay, this is with the color of photograph, brightness or blur. Texture is a actually texture is a degree of roughness or smoothness, and that is actually the physically, if you have some, say, let me tell you, if you have some sample of rock, and if you will just make there is a surface, if you will touch, so in some rocks you feel gritty feeling and some rocks you feel smooth feeling. So that is the texture, rough texture and smooth texture and coarse or rough texture. So here texture means it is a virtual texture. Okay, coarse or rough, sorry, coarse or smooth of an image. That is the regarding image texture, how it looks. Pattern, some particular pattern will be falling. Okay, in your image, suppose if you can say the railway track is going on, and if railway track you will see, and there are some signals or some signal poles or some electric supply line, if that type of pattern or you will see in your image, you can say yes, here in this particular area that is a railway track is going on. Size, that what is the size is also important, that building size, whether it is a, if it is a big one we can say it is auditorium, or if it is some smaller we can say the school building. Shape, shadow, how the shadow means, if the morning image is there, how which type of shadow, if the evening or in the afternoon image. Association, association means if you will find some runway type of a road, and there is something like terminal building, so association of particular features is with which type of a object. And that is the site, what is your site. So these are the primary factors, but these things are also, once again, it is done in a software ALDAS, and that is supervised classification and unsupervised classification. That is there. We will just stop here. But here, this gives the primary level, secondary level, tertiary level, and higher level. Okay. So these are the tone or color. That is a primary level. Means some you can go up to that and you can say that yeah, this is the vegetation or this is the water body or something like that. Size, shape, and texture, that is the secondary level elements. Pattern and shadow is a tertiary, third degree. And sight and association is the higher level elements are there. This is regarding image interpretation. This is the same thing is here, only the some with some detailings are there, but the primary, secondary, tertiary, higher, and it is given here. That is written with some multi-concept or the collection data or evidence and like that. What is the method? Method of search. Okay. Now we will just here go for the demonstration of ADAS imaging software. Here, okay. In this ADAS imaging software, I will just open the ADAS software interface. Is okay. Please, is it visible ADAS imaging software interface?
Yes, sir. Visible, sir.
Okay. Okay. Thank you. Thank you. Okay. So there is a ADAS 2014. This image is there, and here there is a different toolbars and commands are given, and this contains here your different layers will be displayed. Okay, so what is this? This is also here. It's a layer of maybe the whatever your theme or layers are there, that will be displaying here in this box. Okay, so here just I will give you the what is this software. This is related with the remote sensing and it is known as image processing software. Okay, and ArcGIS is a GIS software for working or our task. But normally nowadays ArcGIS also performs some image enhancement process, and ADAS imaging also performs some functions of ArcGIS. But if your particular pure image enhancement work is there or image rectification is there, then you have to go for the ADAS. Here, if you will find here home, manage data, raster and vector. Okay, here raster and vector. This word is very much important to understand concept wise in our geospatial. So actually, you have the idea, but madam, can I go for this raster vector differentiation or what is that? Hello,
Sir,
madam.
sir.
Can I go or
Yes, sir.
the
Yes, sir. Yes, sir. You
okay?
can come.
No, otherwise, if audience is acquainted with these participants, then I can directly go to the exercise.
You can go with the introduction, sir. Raster and vector.
Okay, okay, raster. Fine. Now we have talked about the image and other things. So here I will say raster and I will home file open and raster layer. Here different layers are raster layer, vector layer. Raster layer I will open first here. Okay. Now this is here. Just let me open it first. Then okay, here when you will make the open or you will load the image, it will be just like this. So what you have to do, you have to right click and select fit to frame. So now this is the image I myself downloaded from USGS before, I think 2015 or even maybe 16. So here in this image, if you will see, okay, you just see here where there is now highlighted yellow bar and something written, that is UTM zone 43 WGS 1984. That is the coordinate system. This image is already registered when I downloaded. So here, wherever you will put the cursor, you will get LED launch. This is just for, this is our Ukai reservoir, Tapti river, and then this is downstream and from our Surat city start. And this portion is of our Surat city Arabian Sea, and somewhere here our SUNet is located. So I put cursor here. It shows here in a UTM there is some values are there. This is just for understanding. Now this is a raster. Okay. So actually raster is what? The data or the details collected in terms of a grid. And that grid is a square grid. Its size is there. And in that grid, how much brightness or which type of feature is there? It is known as a picture element. And this is, we can say, our image. Now, what is a vector? So vector is here. If I don't know whether it will, if I will load some vector layer, then will it be evolving? Because randomly, if I am loading, then it may not work. No, sorry. Anyway, I will explain you. So this image now. Vector format means what? Before that, I will explain digitization. So this is the image. And in this image, if I want to mark this Tapi river and this Surat city boundary, okay. So how to do? So that digitization. Now just we will go back in previous years, 20 years before. This image is physically available. You are putting on a drawing table by clipping, and then you are putting tracing paper, and after that you are making using pencil, you are tracing this river Tapi, this feature. Okay, you can go here, here pen tool is also there. Okay, you can penning here, zooming is also there. I will just take this. So this is just the zoom of Surat city, and I told you somewhere here this is actually delta region meeting at the Arabian Sea, and this is like that. So here you can just draw the line with the pencil and tracing paper. You can draw these features, roads and everything. Okay, so that is your you have done the tracing manually. Now same work is done in software, that is known as digitize. So whatever you are clicking here, okay, so the same thing, you are either you are drawing the line or you are putting the pen with the pencil on tracing paper. And when you will take tracing paper out, so on tracing paper only Surat city, river Tapi and Surat city boundary, and it will be there. So that layer is a vector layer. That is a vector layer. But if you are doing it manually, it is known as a tracing done by the draftsman or the tracer. Okay. And that was before this introduction of the software. But now everybody can do this. So that tracing, if you are doing tracing in a software, and now here I have uploaded this image, and now I want to, here I have to click 1 click, 2 click, 3 click, 4 click, okay, and this, and then after so that will be known as a digitization. But here when I am clicking, so this like a tracing paper, it is a physical, here virtual tracing paper you have to create, that is known as shape file, that is known as vector layer. Okay, so this is the main situation. So raster is having the grid and pixel value, while vector layer is having only three features: point features, polyline features, and polygon features. So that is raster and vector. Now still further we will not discuss now much more, but suppose say by camera clicking you have your photograph. If you are going some places on a hill station and there are so many what we can say, the persons are there, सब बैठिए मैं आपका sketch बना देता हूँ, okay, and you are just sitting and then he will make your portrait. So that is what, that is a vector. And जो photograph खींचा है and then whatever we have that photographs, that is a raster. Okay, because that painter is making your drawing is only with using the lines, polygon, and point. Your eyes is just made by the putting the point by the pencil or any color pencil. That is raster and vector. Okay, now we will come to, once again we are switching over to our ADA's image processing and okay. So with this, what is the software, about the software? Now we will go for subset of an image. What is a subset? Because say here in this I have mentioned you that image is there where Surat and surrounding Surat region is also there, Navsari and other upstream, but I want only that Surat city portion. Okay, say here I want only this portion. Okay, this is Arabian Sea. Okay, I don't want this portion. Sorry, I want only this portion, remaining I don't want. So to cut, to crop using the tools, that is known as a subset of image. That is known as, so image may be of this 185 kilometer or whatever the size is there, but we required to cut the area of our interest, that is known as subset of image. Okay, so here in subset of image, what you have to do? You have to create an AOI layer. That AOI layer is nothing but it is a vector form. It is a vector. So AOI full form is area of interest. Just I mentioned that only this much portion I want for my work from this entire image. That is the, so how to do that process? So that is here in this software. Okay, now these are the methods. There are two methods. We will switching over to software. Okay. Here, okay, I have gone to the raster. Then I have to select subset and chi. Okay, this subset and chi, that I have to select. Here, create subset of image. Okay, so this dialog box subset of image is displayed. Here, what is the input image? So detailed or name of my DG image will be displayed here. Okay, here whatever the name is there. Output image, you have to give the name and their location by here. And then after, either you go from inquire box or you give what is X and Y, means your here, what is your X coordinate here to here and Y coordinate here to here. So this box will be selected. So that is there. And another one is there here. Yes, AOI. you upload the vector file. Okay, say Surat city. I have Surat city shape file, or I have boundary of Surat city. So that I have to keep here. So two manner. First, we will see this from any zoom in, zoom out drawing tools, or any random elliptical portion, or any random or by giving coordinate, that we will see first. Okay, so here that is select the file, open raster, select image from the source folder. Image will be loaded in AirDA's interface and displayed. That is over. First, create AOI layer. So you go to home, then inquire from drop down menu, inquire box, and select the portion of image of your interest. Okay, so go to home. Then this is inquire. Okay, after okay, so now here just inquire box. Okay, so this box is displayed here. Now I will bring it here, this box, and whatever the extent I want. So you can enlarge also, you can move this box also. Okay, so this is the box, inquire box is there. So only the area in this square, or whatever may be rectangle, whatever may be the polygon, I want to crop it. Remaining portion is not of my use. Okay, so that is the whatever that box is AOI. Now go to raster tab, create subset of image. Okay, just now so raster, subset and cheap. From drop down menu, select create subset of image. Okay, so subset dialog box will open. Give the input image already there. Output file name. Load AOI file created in step 2 through inquire box. Click OK. Process will start and subset of image will be created. We are going to once again on the software. Oh, sorry, that has gone. Okay. Inquire box. This box is here. Okay, and I have kept it here. This box I am keeping here. Now, this latitude and longitude values x and y, that is given here, that coordinates and that much area is covered. Now go to raster, subset and cheap, create subset of image. And here input file, what is the output file name? I will just give the output file name in my folder, that is the oh sorry, just no. Here I will give the name, say Surat. Now here in if drop down menu, if you will see the image which I am using now, that is a TIFF format. Then there are number of different formats are there. Normally the ADAS is working in .img, image in format. Okay, image in, that is a .img is there. And when this I download, that is in a TIFF, even I can make this in a TIFF format. So I will select that TIFFs. It will remain as it is. Okay, and I will click OK. So you see here, output file is Surat TIFF in that particular folder. Now what is here written? Here Here written that from drop down menu, select image. Okay. Give AOI created by inquire box in step 2. So that is here. Now what is a subset? Subset definition. So from here, you just give from here. Okay. So when you will click this let launch value automatically taken of this box. Okay. And now you go for the okay. So okay, this is the process is completed. Now you can make it close. You can close this also. And now I am going to the once again the file, open raster layer, and okay. Now you see these two are the image. Of course, I have only added this one image. And this is the second image Surat which is created. So I will now load it. So here Surat and this is there. Okay, now you see this is the subset of image. Here only this is the Surat city is there, and this is the entire portion. So only this much portion is cropped or extracted, and that is here. So that is the subset. You can have the panning tool, zooming tool. You can go for this pan. You can go for this zoom. Okay. And you can see once again, this is the thing. So this is the area of interest you can give. But now another method is there. Just let me. Another, this is method 1. Okay, so the same thing. This is my original image. I have selected this area. After this, these are the screenshot of that subset of image. And this is the image. Here at that time I have not when I prepared this, even after sending it to you madam, my note I have also updated. So once again I will send it to you also. So at that time I have not selected that Surat region.
Dear participants, sorry for interruption. Just 2 minutes.
Dear participants, there appears to be a minor technical issue. We request all the participants to please bear with us a few moments as we reconnect with our speaker. Sir, am I audible, sir?
Yeah. Yes.
You can
Okay.
share the screen, sir.
Yes. Okay. Just I will just share the screen once again. Let me. Just it will take 2-3 minutes to open my both ArcGIS and ADAS. So okay, first I am just opening ADAS first, and then I will open my PPT and I will resume. Hmm. Is it presentation is there now, madam?
Yes, sir. Clear, sir.
Okay. I'm going to that. Yes, here we were. And let me have this. Okay. Are you able to see now ADAS also?
Yes, sir. Yes, sir.
Okay. So this is the Surat which I told you that. Okay. So now this is there, and these things we have already seen, and now using shapefile. So here, what is this using shapefile means? Oh, sorry. Here I am just closing this thing. So I have not saved the work. Okay. Now we will once again loading the same image file, open raster layer, recent, and okay, the same image. We are loading and then fit to frame. Okay, sorry, this is different one. Let me take the same once again. Okay, now here this is the image. Now this is a first method. Now my Surat city map I have. Okay, so that Surat city boundary is there with me, and I want to create the cropping subset of that shape. Okay, so now we are coming once again here. Okay, so method 2, select the file, open raster layer, image will be loaded. Same, select file, open vector layer, select the shape file from the source folder. Okay, now this is important. Shape file will be loaded in ATA's image interface and display. So this is the file. We will take this first now. Open vector layer. This is through shape file. Okay, now this is Surat boundary bnd.shp. Shape file has a .shp extension and raster has so many extensions are there. Just I will show you in ArcGIS software. So this you load it. Okay, now you see this is the shape of Surat city. Just 1 minute. મિતેશ હું ફોન કરું હમણાં ઓનલાઈન લેક્ચર લઉં છું. હા ઓકે હું કરું. Okay, so now you can have the zoom layer. Okay, so now this is from the shape file means what? This entire image I will cut or crop using this shape file. So this image will be just given, I will get on this shape. So this is the shape file and the boundary of this. So now what are the next step? Click the shape file, it will be selected and its color will change. Click the paste tab from menu bar, AOI with dotted line will be created. Click the shape file once again and a box covering AOI will be created. Okay, so these things are there. These are the process. So here just 1 minute. Sorry, just I have to change the tool. Select okay, now here you can choose the, this is by default, this color is coming. You can choose the color from here also. Okay, now go to home, there is a paste. Okay, okay, this is the Okay, this is the paste. Now you see this is the dotted line is created around this. Okay, so now we will have to just so here first of all I have loaded this file, I mean save file. I clicked it, color change, and then I have make the paste. So this dotted line is created. Now once again I have to create. Okay, so now you see this is a AOI is created. This AOI boundary, AOI box, but the exact AOI is this shape. Once again we will go for. Then what's the next? Okay, click the shape file. It will be selected. Its color will be changed. Click the paste tab. AOI of dotted line will be created. Click the shape file. Once again, a box covering AOI will be created. Okay. Now once again, the same process. Go to raster tab to create the subset raster, subset and chip. From drop down menu, select the create subset image. Okay, subset dialog box will open. Give input image, give already output name. Okay, and now here we will change will come in step number 10. Okay, raster subset, this is there. Now once again I am giving that name. Okay, here this is img format. I am just making and changing it TIFF. Okay, so here I will give the name is a Surat one here. Okay, here Surat one and okay. So here Surat one TIFF is a output file name created, and previous step we have gone from inquire box. No, now go for AOI. So after this AOI, what you have to select here? You have to select the viewer. Okay, make sure that is one AOI selected in the viewer and then click OK. So okay, when you will make this viewer, then only one AOI should be there. Otherwise, the software will get confused. If you will say this AOI, then this AOI can also be saved as a .AOI format. And if you have already saved previously, that also you can load here using this and using this box. But no, now from viewer and okay. Okay, and now I will just give this click OK. So there is a process is there, process is over and close. And once again, here you see this is already this layer is created. Okay, so this created layer, if I can use directly next time, then it can work. That is the meaning. I will open the raster. Expert exercise, sorry. Here there is a .img format is displayed. Yes, you see here this much, this many formats are here, number of formats are there. Okay, but for all the formats I have also not that knowledge. Normally that remote sensing, image interpretation, image enhancement, and other things, electronics people, physics people, they are also working. I told you initially just we are the driver, driving the new car and other things. I will select if, what is that? Surat 1. Okay, so I will load it, Surat 1. Surat 1 is loaded, and oh, sorry. So this file, this is created, this portion, okay. This is now my file of a Surat city exactly covering the boundary of Surat, and the previous one was a only some portion randomly covering Surat and surrounding region. Okay. So this is my this is the Surat boundary map, which I can remove the layer. You can remove also layer. This is the AOI. You can remove the layer. Otherwise we will be out. So only this is my image. Okay. So this is the subset of image by the method number 2. Okay. So either your random shape you give, coordinates you give, and another one is you give specific shape file. It is a vector layer. Okay, here mosaicing is also there, but madam,
Yes, sir.
madam, okay, I am at present just I am skipping this mosaic, and now I am directly going to ArcGIS and water delineation. Will it do? Because and how much time is now remaining? Hello, madam.
Hello, sir.
I am just going to next
Sir,
exercise, ArcGIS, mosaic. I am just skipping that. And how much time is remaining? Actually, scheduled time is 7:30. But
yes, sir. 10 more
how
minutes,
much
sir.
can I? Yes, please.
10 more minutes, sir. Actually,
Okay.
this
10,
session starts at 7:30, sir.
Okay. So I am going to this watershed delineation. Okay. So watershed delineation is what? It is the area is there, and in that area we have to find if rainfall is there, then water at a particular junction, how much area will contribute the water. Okay, there is a watershed delineation process here. That is nothing but for that we require DEM, because the DEM will give you undulations and flow direction. We will be going to that, and before what we have to do in the process: identify the outlet, determine flow direction, delineate the boundary, refine the boundary if required, and automated methods. Okay, so here procedure and the software. What is this? We will first, let me first open the ArcGIS software. I am just making this close. Okay, I am opening the ArcGIS. Okay, this is ArcGIS software is open, and here already I have prepared that, so I can put that as open, and this everything is here. Okay, but I will show you. I will be just, this is the entire exercise I have processed, and this is the watershed delineation is there, delineated map is there, but without wasting much more time. Okay, I am opening the blank map. Okay, so here we will see the first thing is a what is this software and tools. GIS software and in GIS hydrology tool is there. Input data digital elevation model. Okay, then we have to go for this field, flow direction, flow accumulation, stream network, watershed delineation. Okay, that is the final step. So how to start? So we will first open the, we will add the DEM layer. Okay, this is the add data tool. This is SRTM DEM. I am adding this and I will give some different colors. You can change as per your. So this is DEM, and here once again in WGS 1984 coded system is there, and this is now here what we have to do. So here first step is here is fill. Okay, we have to find the fill raster. So open toolbox, parcel analyst, hydrologist, select the fill tool, give input raster, give location of output raster, click OK, and this is a display. So here, so, okay, here this is the toolbox. Okay, open the. This is the toolbox. There is a spatial analyst tool. In spatial analyst, hydrology and fill. Okay, this I have. So here, what is the input raster? Input raster is this SRTM, this tin, this DEM. Okay, this is my input raster. Then output raster is this. He is given. You can choose of your own folder also, but don't forget here your layer, layer name is this. You can change here that layer. By going here, you can change the location also. But here default.gdb, because now the layer we are creating is a geo database. So if you will not store it in geo database, then your process will be failed. So that you keep in mind, and due to time constraint, I am keeping it same, and I will say okay. Okay. So here the process is just going on. Sometimes it will be displayed here at the down also. Okay, you see this is the fill SRTM1. You can change the color also, not the same, but say something different. Okay, just I have selected. Second step is here. After the fill, after the fill, flow direction. Okay, where the flow will go. Once again, same toolbox, and we have to go to the flow direction raster. So here you just go to the same.
Hello, sir. Dear participants, sorry for interruption, just few minutes. Dear participants, session is not completed due to some technical issue. Just be patient, just few minutes.
So these are there are the steps of flow direction, okay, accumulation, streamline, and finally water delineation. That are the steps in ArcGIS. So anyway, it is the second time my computer, whatever it may be, it was hang. So just I make that concluded the session that both these software editors and ArcGIS is a very much important software tools for research work and any other type of technical engineering project work. So thank you, madam, to you and your team and your call institute management to giving me this opportunity. So I'm just concluding my session. Now over to madam, please.
Thank you, sir. Thank you, Professor Agnihotri, sir, for your very informative and hands-on session on remote sensing and GIS tools. The demonstration of watershed delineation was highly practical and insightful. Now we'll proceed to the interactive question and answer session. Participants who wish to ask questions may can ask, or you can post your questions in chat box.
Okay, as per the wish of participants, even they can contact me on my mobile also and email also. You can give it in your, okay, at present, suppose by chance, and if anybody else, just please ask so that another session can be run.
Participants can ask your questions, or you can post in chat box also. So one question, sir.
Yes, free
Is
software is available. That is of only up to some limited access. You cannot do all the. I don't think about this. In our geospatial app, we have purchased licensed software. How we can validate results obtained by our GIS? No, already here we have to, when we are doing the work, we there is a also one requirement is the ground truth verification. So by uploading the image, some key points, key feature we have to check by going to that particular place, even by taking GPS, so that we can verify net launch also. Okay.
participants any more questions? On behalf of the organizing committee and all participants, I sincerely express our gratitude to Professor PG Agnihotri sir for sparing his valuable time and sharing his rich expertise with us today. We also thank all participants for their active engagement throughout the session. With this, we conclude the first session of our ACTE ATAL Faculty Development Program on data acquisition and study tools using RSNGAS and exercise on watershed delineation.
Okay,
We'll
madam.
rejoin shortly for the next session. Thank you, sir. Thank you very much, sir.
Okay. So thank you, madam, and your entire organizing committee. Just I am leaving the meeting. Thank you very much.
Yes, sir. Sure, sir. Thank you, sir.
Okay.
Welcome to the session 2 of the day 4 of ACTE ATAL Faculty Development Program on Sustainable Practices and Innovative Trends in Civil Engineering. Our next expert session is by Dr. Jaikumar Seelam Sir, Chief Scientist at CSIR NIO Goa, on renewable energy opportunities along the inlets and estuaries of India. Before we begin, I now invite our faculty colleague Dr. G. Giridhar, Associate Professor, to formally introduce our eminent speaker to the audience. Over to you, sir.
Good evening to one and all. It gives me immense pleasure to introduce today's distinguished speaker, Professor Jaikumar Sir, a dynamic professional in the field of civil and coastal engineering. Professor Jaikumar Sir is a chief scientist at CSIR, National Institute of Oceanography, Goa. He is also a professor at the School of Oceanography, Academy of Scientific and Innovative Research. He is currently serving as a member of Expert Appraisal Committee of the Ministry of Environment, Forest and Climate Change and Governing Council of National Institute of Wind Energy, Ministry of New and Renewable Energies. Professor Seelam studied BTech in Civil Engineering from Sri Venkateswara University, Tirupati, MTech in Ocean Engineering from IIT Madras, and PhD from University of Queensland, Australia. Professor Jaikumar Sir is a fellow of the Institute of Engineers and the Institute of and Indian Society of Hydraulics, life member of the Ocean Society of India, Indian Society of Remote Sensing, the Indian Science Congress Association, and member of International Association for Hydraulics Research. Currently, he is a vice president of the Ocean Society of India. Professor Seelam Sir's research interest in coastal process, waves, tides, currents, beach processes, sediment transport, impacts of extreme events and climate change on coasts, storm surges, rip currents, tsunami propagation, and inundation, etc. He has been trained in coastal process modeling by DHI Denmark and tsunami modeling by the UNESCO IOC. Professor Seelam is versed with field observations, laboratory studies, as well as numerical modeling of coastal process. He has more than 120 publications in reputed international journals, conferences, book chapters, invited talks, and he is a reviewer for international scientific journals. He has guided 7 PhD students, 24 master's theses, 22 internship guidance, and currently 3 PhD students are pursuing their research under his guidance. He is also actively involved in consultancy and research projects for the coastal industry sector, especially on environmental impact assessment, measurement, and modeling of coastal process. It gives me great pride to say that I worked under him and gained valuable knowledge and experience. We are truly honored to have such a versatile and inspiring personality with us today. Thank you for accepting our invitation, sir. Now, please join me in warmly welcoming Professor Jaikumar sir to deliver his session and share his valuable insights with us. Thank you very much, one and all. We welcome you, sir. Thank you.
Good evening, everyone. Thank you, Dr. Giridhar, for your warm introduction. And first of all, I would like to place on record appreciation and thanks to LB College of Engineering and this FDP program coordinator and Dr. Arnima, I believe helped by Dr. Ramya and HOD Dr. Naidu Garu. This is I would like to share my screen while I'm talking, so I'm just trying to do that as well. Can you please unshare?
So you can share your screen, sir.
Okay, so is my presentation visible in full screen?
Yes, sir. Visible, sir.
Yeah, thank you. I'm going to switch off my video so that I don't distract and I don't get distracted. Um, Before I continue, I'd like to place again, once again, thanks to ACTE, ATAL FD program, LBC, LB College of Engineering, and my institute director, and my PhD students and project staff, without whose help this research would have not been there. So, sorry, I am not okay, but then still I thought, okay, since I gave my time, I wanted to finish this talk for the benefit of almost like 300 participants. It's one of the large gathering I heard from Dr. Nima and Dr. Ramya. I've placed my title as slightly I changed. I removed the estuaries because tidal inlets and estuaries are almost like similar for me. So I like to look at little bit on renewable energy opportunities along the inlets of India. As already introduced, I'm my qualifications and all already told. I'll not go more into this, but this is before we jump into the subject. Since people are there from all walks of life and many faculty are there who are aware and who are not aware of what is CSR, what is NIO. CSR is the Council of Scientific and Industrial Research under Department of Scientific and Industrial Research of Ministry of Science and Technology with 37 laboratories. National Institute of Oceanography, which is in Goa, is one of the 37 laboratories. Our headquarters is in Donapola, and we have regional centers in Visakhapatnam, Mumbai, and Kochi. We are here almost like 60 years. We are here, and institute works on all aspects of oceanography. Any subject you take, let it be physics, chemistry, biology, geology, archaeology, engineering, instrumentation. So we have scientists working on that. Our focus is mostly on observing and understanding the oceans around us. Apart from this one, we have two research vessels right now, which are up and running, on which our oceanographic scientists are working all over the Indian Ocean. And we are about 300 scientific and technical staff. We are affiliated with ACSR. We have a School of Oceanography from which PhDs are being awarded. So the website of our institute is nio.res.in. People who are interested can look at the website, and then if for more information, they can get from that. That's about NIO. And what do we do at NIO? If I take my name or my group, we have done a lot of works. We look into a lot of issue related to coastal physical processes, wherein we look at sediment transport, surf zone dynamics, where currents are there, tsunamis, coastal hazards, measurements and modeling of waves, tides, currents, sediment transport morphology. So we have a lot of portfolio. So we have, since this is ocean is large, and basically for us, ocean engineering is application of civil engineering in oceans. That is what we have been trained at in the present department. But any engineering in oceans, any application of engineering oceans comes under ocean engineering. So this is about briefly, we will be looking at the ocean energy part, and wherein we will slightly go into different types of ocean energies available, and then I'll focus more on the wave energy and the tidal stream energy. So as we know that we have multiple renewable energy sources. Main one, the largest one is the solar energy. Next is the wind energy. We have hydrogen energy, ocean energy comes in there. Hydropower, most of the civil engineers are well aware of. Geothermal, which is temperature difference on the earth, and bio energy is there. So out of these, we are more focused on ocean part. So people who are seen the beaches, they only look at the very close by, which is close where the waves break. But then if you want to look at how deep is the ocean and how wide is the ocean, you can go and have a look at what is the ocean relief. So you can see on the left hand side is the depth, wherein you say up to 200 meters, we call it as a continental shelf. Then we have a continental slope, then raise, abyssal plain, and we have almost like a 10-kilometer depth oceanic trenches, and more than, on an average, the ocean average depth is around 4,000 meters, that is 4 kilometers. So we have almost like 4 kilometers of water before you reach the seabed. Apart from that, we have volcanic islands, atolls are there, submarine ridges are there. So all these things are there, just like what we have on the land. We have hills, mountains, valleys, rivers. Similar things are also available, are there in the oceans, but otherwise we see only the water surface. Our interest mostly, if you look at, is in this region, close to the coast, also known as the littoral region, wherein we can see the waves breaking, and which is also influenced by the tides and waves. Okay, so there are a lot of definitions on what is high tide, low tide, wave breaking, terrace, subzone, all these things, but we'll not go into that right now. So if you look at the temperature profile of the oceans, normally when you take any lake or in the rivers, we see almost similar water temperature in the water depth. But then if you go into the oceans, if you look at the depth, with the depth, the temperature changes. So here, this is a typical figure. This is not exact figure. If you go into measurements, you see that by the time you reach 4 kilometers or 1 kilometer, you see the temperatures have come down to single digits. That is in the tropical areas. Tropical is shown by the red color. Mid latitude and polar has a different temperature profile. Polar, you don't have much of temperature changes, but in the tropical areas, we can see almost like 20 plus degrees variation, temperature difference within 1,000 meters water depth. So this is the unique feature of oceans, our oceans. And winds is another peculiar feature, which because of which waves are formed. We most of you on the east coast have experienced a recent cyclone, so you have seen the winds coming in without any obstruction. But if it is on the land, you have hills, you have trees, you have large valleys, are these ones which will obstruct the winds, and then your wind flow will be slightly changed with the terrain. Whereas in the oceans, it's almost like flat water surface, so you'll not have any obstruction for the winds to blow. Coming to the waves, it's another physical property of oceans, where basically waves are generated by winds. So if you look at this tug or a fishing vessel which is coming in, you can see how high it goes, and then it just thugs on the sea surface. That's not only because of the motion of the vessel or the ship, but also because of the up and down motion of the water, which is typically we call it as waves. Another phenomena, physical phenomena, most of us in the northern regions of India are well aware of the tides, even in the southern port. But then we have large tidal ranges. When you say tide ranges, the tides will come a little bit later on why tides and how tides are generated. But you can see at the same location, when it is low tide, there's almost like 6 meters water is gone. In the high tide, you get another, you'll have water level. So this variation is typical for the tropical as well as almost all the coastal areas, where this is influenced by the sun, moon, and earth gravity. So this is one other phenomena which is mostly in the oceans. We make use of this for energy generation. If you look at the chemical composition, I'm just bringing the chemical because people may be interested in when you say seawater, we have a lot of salt. Can it be used as a electrolyte, or can you use electrochemical reactions? So yes, there are many ways which we can seawater can be used for generating energy. There are now what is known as lanterns, seawater lanterns or sea lanterns, which they use seawater and then magnesium they use, so that generates a transfer of electrons, and then a light is blown. So this is another form of non-renewable energy, which is based on the chemical composition. So there are, I just briefed about different components of wind, wave, tide, and then solar or chemical. So all these things can be used in the energy generation. So at NIO, since we are there from 1966, many people have worked on different topics of these things. Floating solar is very recent, which we are starting now on engineering aspects. Otherwise, on ocean thermal energy, wave energy, offshore wind energy, floating solar, these are the ones which we normally work on. So OTEC, this is the general acronym for Ocean Thermal Energy Conversion. This in India we have a potential of 180 gigawatts. This is a theoretical potential of our Indian Ocean. This source is from the MNRE, that's the Ministry of New and Renewable Energy. Even though we have 180 gigawatts, it's not that we can go and harness it immediately, because we are dealing with the oceans. It's a harsh environment, and we are talking about 1 to 2 kilometer going underwater. So having pipelines of 1 to 2 kilometer long, vertically hanging from the surface. So it's not going to be easy task. Or one of the institutes in India has already started working on it, and they are going further with new tests. So we talked about the temperature variation. That's on the left side. We have put in small figure. That there is a lot of variation in the temperature. So how can this be used to convert or to generate energy? So if you think about refrigerator or air conditioning, we give power to the condenser, wherein the fluid, which is the cooling fluid, gets compressed and then comes in, and then because of this compression and the expansion of because of the heat, there is a exchange of energy. So now, if you think about going backwards, or back engineering, you say. So what if you have two different temperatures, one cold water and one hot water, and then use the cooling fluid, so that can that generate or run turbine? So this is the similar concept wherein the cold water is taken and then it is used to condense. Here they use ammonia. It's ammonia pump is used here. There are other fluids which are used somewhere else. So use the cold water to compress or condense the fluid and run through the pump, and then the hot water or the warm water becomes helpful to evaporate this ammonia. So there is like evaporation is there, which will run the turbine, and then it gets cooled. So this kind of cycle helps in generating or converting the difference in the ocean water temperature into useful energy. Using this technique, instead of not only running the turbine, we can also get fresh water out of the seawater, because once we evaporate the seawater, the salts will be coming out as a brine, and then the fresh water is coming in terms of vapor. This vapor is condensed or cooled and used for use of the islands. In the Lakshadweep Islands, this method of taking the cold water from deeper water and then making into fresh water is already in place by a technique known as LTTD, low temperature thermal desalination plants. These are already in place for Lakshadweep Islands. This is in a nation stage for India, not only India, it's on the world also. Very few thermal energy conversion platforms are available. So India has been trying, and then work is again restarted by National Institute of Ocean Technology, Chennai. So where this can be used is, if you look at our Lakshadweep Islands, where the water depths around the islands are about thousands of meters, and then suddenly we get the land part. So if you take a cross section of let's say 500 meters, if you go into the waters, we may get more than 1000 meters water depth. So horizontal, if you go even 10-20 meters, we reach 100 meters water depth. So it's very steep islands here. So that is how this is the where. And not only that, these places we don't have any kind of other energy sources. So earlier, before the solar panels and all came in, there used to be supply of diesel, and based on diesel generators, all the power used to come for all these islands. Nowadays, solar has come, wind has come, so they have installed solar and wind, and that's how the renewable energy power is being used in the islands. We have been working, or let's say more than 30 years back, 40 years back, people have started working on the efficiencies of VOTEC potentials of sites along the Indian coast. This is one paper in 1983 by our former scientists. This is another paper by another group of scientists wherein they talk about thermal energy conversion by coupling solar plants and then seawater. This is another one in 1986, wherein they look at seasonal variations in potential of Indian coast. So this is not a new topic for our nation's oceanography. However, because of the issues with funding and importance given to this kind of research, it could have been kept aside. So till a national ocean technology was formed, this topic was not much looked at. That's about ocean thermal energy conversion. Next is on the waves, because I thought we'll talk a little bit on the ocean energy, then go into tidal stream energy. So this is on wave energy. So when you talk about wave energy, the important one is wave. We have seen the picture of the ship moving on the waves. So if I take that snapshot of the sea surface and then look at how the sea surface looks like, we can see the water surface undulations. So in general, mathematical terms, to be easy, a sine wave or cosine wave is considered, and then analysis is done based on that kind of waves. So normally wave height is taken by the difference between the trough and the crest, and then the wavelength is any equal distance between the two troughs or two crests. So these are the typical properties of waves: wave height, wave period, or wavelength, and then depending on the water depth, deep water conditions or shallow water conditions or intermediate water conditions, we can have different kinds of um, waves which can come in. So now what here we are seeing in comparison with the movie, what we have seen is here it's all very smooth waves. When where with the movie we had a lot of wave breaking was there. Nevertheless, whenever there is a movement, so water is moving up and down. So that's a mechanical motion. So whenever we have a mechanical motion, that can be converted through gears or into electrical energy. So that's the concept used in converting our waves into wave energy, useful wave energy. So now, when you talk about wave energy, there are the research has been for many decades. There have been many thoughts or different approaches which have been put forward. Many patents are there on how do you convert these waves into energy, useful energy, but very few equipment are actually in the field. On the left hand side, if you can see my mouse, this is one of the aquaret, what is but below one, this is known as duck, Salter's duck, done by one Professor Salter in University of Edinburgh. So this is a huge one. It looks very small, but it's almost like 5 to 6 meters diameter and then 10 meters long. It is very long structure. It's only a cross section. So these are kind of units are already designed and then put in place, but they're all experimental. So these are all moving with the wave motion, up and down motion. So same way in terms of there are many terminologies used or many types of wave energy devices. Like this is a wave point absorber, wherein when the wave goes up, the float goes up. When the wave comes down, that is when the trough comes in, the float comes down. This up and down motion is converted into a piston motion, and then whether through a hydraulic energy or by using directly um, solenoids or for turbines, we can convert this mechanical energy into electrical energy. This is one point absorber method. So this is another one wherein it's like a dam. Whenever you have waves coming in, so if you allow a slope because of the wave run up, the water can come and then fill up in the reservoir. This is a reservoir on top. It's all floating. Okay, so once the reservoir fills up, so there is a head. That head can drive turbine by opening by releasing the excess water through openings below. So this will be a turbine below, and then there is a reservoir. So whenever this is almost like our hydel power, wherein once we have enough head, we can open the gates and then the turbine can run. This again is because of waves. So that is one another one. Attenuator basically it's like a long snake-like thing with hinges. So whenever the waves go up one place, but there is a trough is means crest is one place, the trough is another place. There is an inclination for it. So this up and down motion of these hinges can be converted again into electrical energy, mechanical to electrical energy. Oscillating water column, OWC we call it, is one successfully demonstrated in India in the Kerala, Vizhinjam port. So this work was way back in the 90s, early 90s when we were studying. This basically is when the wave comes in, it's close to the coast, it's almost like touching the land. What will happen is when the wave comes here, this is open to air. So this water movement will push the air up. So whenever the wave comes in, the air goes up and then that runs a turbine. And then when waves go down, that's a falling water column. And again, during that time, the air will come down. So because of which the turbine again runs. So this will have a same, it means whether water curve goes up, means air goes up or down, the turbine will be rotating in the same direction. So that kind of turbines are used here, unidirectional turbines, to convert the waves movement into electrical energy. So this is another one like inverted pendulum, wherein the float moves along the wave crest to trough. That is converted into hydraulic pump or hydraulic engine, which generates pressure that can be either used underwater or on the shore to generate other turbines. So this is basically, there are many ways we can convert the mechanical part of the waves into electrical energy. A lot of research is needed in this aspect of different types of testing, a lot of CAD, CAM simulations. If you look at the patents first, if anybody was interested, look at the patents, what are available, how many have actually worked or how many didn't work, why they didn't work. All these things are required before we jump and then say, yes, we are going to do or build something in terms of wave energy. These are in the field, which are already existing. So this is done by a Danish company known as Wavestar or WEC Wavestar, wherein this is a pendulum like whenever the waves comes up or down, this float goes up and down. That movement is converted into electrical energy inside this. This is a jacket structure in which the Kaizen type of things. You have the wave energy conversion devices with inside itself. So this is one of the successful one, which is already in place more than I think 3-4 years. It has been working. This started as a pilot project, but it is still working now. So this we'll talk about it during my further talk about when we talk about wave energy conversion. Again, since we are there for long, so there have been a lot of work or interest in NIO on ocean energy. This is one of the earliest papers in 1989, wherein Professor Raju from IIT Madras, Dr. Chandramohan and Bunak from NIO, they worked on how much wave power is available. This again, the database based on the ship observations. So ship observations is whenever the vessels or ships go from one place to other, they are supposed to report morning and evening. What is the sea state? When you say sea state, what is the wave height, wave direction, wave conditions and all. So based on that, wave atlas was made by NIO, and then based on the wave atlas data, wave power was estimated. So this is by another scientist who has also done some work in the 90s, early 90s. So this is our recent works by our last one decade, is actually 2015. 2015, it's on assessment around the Indian shelves. It's not just NIO, but there are other institutes which have been working on these wave energy assessments. IIT Madras is one, IIT Bombay. We have another institute, National Center for Earth Sciences in Kerala. So we are a group of small scientists in India who are working closely on these assessments. There is a technical standard on how this can be assessed. So based on this, a lot of assessments are to be done. Now, when you talk about waves, waves are predictable because waves are generally driven by winds. So at NIO, we have a wave model using another software, which is commercial software known as Mike by DHI. So this software we used for generating the waves for more than 50 plus years. Right from 1970 to 2024, we have simulated waves at for every 1 hour for all these regions, what you see here, right from south, minus 60 degrees south, till Bay of Bengal and Arabian Sea. Okay, this is a coarse resolution of the spatial resolution. What we call is a coarse grid, about 2 to 2.5 degrees in the open ocean, as well as around 25 kilometers close to the coast. This information is available. We have used it for PhDs and then writing papers also on wave climate variations. This based on that. Apart from that, also we included the cyclones. Because on the east coast, cyclones have major impact. That means we have high energy waves during cyclones. So how much will be the variation of because of the cyclones? So we have included that also. We have a database, but this is for almost like uh, 20 to 30 years of wave data, including cyclones, is available. So with this information, we need to update the wave energy assessment. So anybody is interested to work on or to further look into this, please contact us. So we'll be happy to work together on these wave energy assessments, as well as going further on types of devices testing of these things. So this is a typical wave energy assessment of our west coast, Goa coast. What you see, these contours are in terms of kilowatt per meter length of uh, wavelength or wave crest length. So we have very almost like 20 kilowatts in water depths of about 100 meters, which comes down to less than 10 kilowatt per meter when you come close to the coast. When you come very close to the coast, it's hardly about 1 to 1.5 kilowatts per meter length. So that's the reason most of the wave energy devices are much farther away from the coast. When you go farther away, there are technical issues that we need to have longer cables for converting that. We'll have issues in what you call marine hazards, fishing issues will come, fishing vessels. So there are other things associated with ocean energy or energy devices. Some exercises we have done based on these wave energies. We have simulated, let's say, for almost like a year. So we see that P1 is in 150 meters water depth, and then P10 is around 5 meters water depth. If you look at the variation in the wave power, the green one, which is P1, which is in 150 meters, it has got almost like 200 kilowatt during the monsoon, or on an average about sorry, about 250 kilowatt per meter when you come to the deeper waters. Same thing if you look at the last curve, which is the pink one, we have almost like touching close to the zero, or it's like very shallow, very low energy. Even during monsoon, it does not go beyond 50 or 60 kilowatt per meter. These are the averages if you look at that. So monthly mean, if you take, we have very less. The black one is for P9 or P10. If you see, it's less than 30 kilowatt per meter. If you look at the variation from 100 meters to 150 meters water depth, how the wave energy variation is there. So close to the coast, which is P10, is less than 10. And then close to the deeper waters are 150 meters. We have almost like 30 to 40 kilowatt per meter. So we have looked at both mean, that is the average power, as well as median power. So we need to be very careful. If you take mean, since we have monsoon waves are high, so mean energy tends to go up. But then if you look at the median one, which is like most often available energy, so that's what we need to consider the median power when you talk about large variations in the wave energy power. Did some same exercise. If you take the length of Goa about 160 kilometers, since we cannot have the entire length of Goa with filled with wave energy or wave systems, so I take the same device, which is the wave star energy, which is shown in the bottom right corner. If I take that power device and give efficiency about 50%, even if I take 10% of the coastline of Goa, it's about 16 kilometers, we can get almost like 80 megawatts. But then there should be interest in the state as well as center, and people should come for putting up these kind of devices. There are issues. That issues are that these equipment or the Wavestar are designed are fine tuned for high wave energy locations, whereas for us, the energies are low. Whether the same equipment can be used in our Indian conditions is a big question. So that is where the research is needed. And that is where we would like to go further and then request faculty members to put the students or they themselves can work on this further. So when you talk about wave energy and close to the coast, since we said we'll talk about the tides has influence on the waves when you come close to the coast. So if you look at blue curve, the blue curve is including the tides. So that's what you are showing is the wave power. So if you look at the wave power variation over the let's say 2 months, if you consider tide, actually the values come down in the shallow waters. But in the deeper waters, that's about 100 meters, 150 meters, the tide doesn't act much on the waves. So that's another reason why wave energy devices are kept further away compared to the coast. So this is one publication which we recently this year in January it has come out, wherein we looked at what are the works done on the wave energy along the Indian coast. Is a review paper. It's available online. This will give a glimpse of what has happened so far and what way forward as well. This is about wave energy. So we look at the wind energy. Again, I said wind. We have similar to what we have in the wind turbines in the land. But if you look at wind turbines, they are placed strategically on top of the hills or where there is a Venturi effect or where we get concentration of wind energy. This is because the topography plays a major role in concentrating the wind energy. However, if you look at the oceans, there are no obstructions for the wind to blow along the ocean surface. So the number of wind turbines can be much, much greater, much larger. So the concentration of turbines will increase. So that way, the power plant efficiency will increase. Number of turbines we can put more. And this is one area where Government of India has gone further in the offshore wind energy. So we have worked on that and assessments a decade ago and looking at different locations where we can have offshore wind farms. So myself along with my colleagues and students, we have worked on this and then we found out there are places like in West Coast, Ratnagiri in Maharashtra area where we have very good potential apart from Gujarat and Tamil Nadu, which government of India has already gone ahead with floating the tenders for offshore wind energy. So this is of Mumbai, Ratnagiri, of Mangalore. We have taken very various parameters on finalizing why these locations and then at what water depth, including shipping routes, fishing activities, and then closeness to the ports. So a lot of things we have taken. So the figures are blurry. You can look at my presentation, which is shared already. We can look at the paper for more information on that. So as I mentioned, already Government of India has brought out a lot of schemes like viability gap funding for offshore wind energy. Already for tenders have been invited for 4 gigawatts offshore wind energy project of Tamil Nadu. Already there is a request for selection of document for offshore wind power in Gujarat. Gujarat. So this is where offshore wind energy is right now. This is our main topic, which I thought will give more importance, which is the tidal energy or tidal stream energy. But however, I thought no, it's just if you talk only tide, it doesn't give any importance for the entire ocean energy. That's the reason I included offshore wind, offshore wave energy, and offshore OTEC also into my presentation. So in talk about tidal energy, when you say tidal energy, tide is more important. So uh, if you want to take a break, can you take a break of a minute or two? Okay. So tidal energy, or let me stop here and then ask, are there any questions or doubts on till now? Because tidal energy with this, after this, we'll be stopping this.
Sir, there is another session. There is separate session, sir, for this question and answers.
Okay, fine. So then because I have another 50% of the talk now, which will go further. Yeah, thank you.
After the session, we'll have that question and answer session, sir.
Okay, fine.
Thank you, sir.
So when you talk about tidal energy, the tide is the major one, and most of us know full moon and new moon. And that is one major reason why we have the tides along the globe. So the rise and fall of ocean waters, because of the gravity between moon and earth and sun, that defines the changes in the water levels, apart from the centrifugal force of the earth, because earth is moving in its own axis, and moon is having its own axis, and both the gravity that helps in the water to bulge in one direction. And that's how some places we get high tides, some places we get low tides, sorry, spring tides, sometimes we get neap tides, and then some other times we get what is known as uh, quarter moon, this one, there we get less tidal water. So this is figure already I showed earlier. So when we have high tide, waters will be coming up. So we'll have water filled up in the basins or near the coast. During the low tide, we get the water going away from the place, and then we get very almost like a nil. So if we talk like a barrage or like a dam, when the water is full, you can close the dam, and then when the water is low on the other side, you can open and then let the water go. So putting a turbine there, it becomes again like a hydraulic energy that can be used because of the head. So that's the main concept when you talk about tidal energy. But there is another one which is known as a tidal stream. So tidal barrage is the same in which we said. You can block the water once the high water comes in, and when the low water comes or the low tide is there, you can release the water or really open the dam, open the gates. So that is where those kind of structures are known as tidal barrages. The other one is tidal streams. When you say tidal stream, because of the tide, water goes in and comes out. High tide water goes in into the river, and low tide water goes back into the ocean. So that movement creates a flow, river flow, or near the tidal stream. So those flows are known as tidal stream. That can be converted into kinetic energy. So these are the two. One is the potential energy based on the barrage method. Other one is kinetic energy from the streams. Sorry. So tidal energy is preferred because tides are highly predictable, because the rotation of the earth, the sun, moon are well predicted. We can predict for decades or even centuries, because the constituents are not much changing unless there is a change in the sun inclination or moon inclination or earth's inclination or some other meteoritic activity. Otherwise, we can predict the tides well in advance. When compared to wind, the density of water is much higher, almost like 800 times. So when you use the same turbine for the same surface area of the wings, you have much higher water power than the winds. However, these we don't have high velocities. When you say high velocities, winds go more than 110 kilometer per hour or even 200 kilometer per hour during the cyclones. Otherwise, normally we talk about 30 to 40 or 60 kilometer per hour wind speeds. Whereas when you come to the flows, river flows, or not river, in the tidal one, we have in Indian conditions very less. But if you go into the European conditions, we get almost like 3 to 4 meter per second current speeds because of the tidal flow. And another one is aesthetics. Unlike the wind turbines, which is an eyesore for many, not for us right now, but then for many places, This tidal energies can be minimal, visual impact will be less. So the barrage system, as I mentioned earlier, is like if when the high tide is there, even when the water can go inside, during that time also turbine can operate. Even when the water is going out during the tide going out, that is during low tide, even that time turbine can be operated. So both ways we can use and then generate energy. So this is a tidal barrage system. In the tidal barrage system, we are talking about the head. So head, if you know the head, that is because of the wave, sorry, because of the tidal range. When you say tidal range, that range is between the high tide, difference between the low tide and the high tide. So once we know that, and then the area of cross section is known, so we can get the potential energy, how much it can be stored. So whether any work is done on this or not. So this is basically when we have a river on one side, a sea on other side, and where we have the river inlet, or that is known as the inlet. So this wherever we have a tidal influence, those river inlets are known as tidal inlets. If there is no tidal influence, they are mostly known as rivers or simply inlets. Okay. So the area close to the river is known as estuaries. That is why in my title I said tidal inlets and estuaries. So similar to the hydraulic dam, what we said, once the tide comes in, if we block this area by a barrage and then put turbines, so during the high tide, water can come in, and then once you close the door gates, and then once we have the low tide, we can have the turbines running. So this is the same mechanism everywhere if you are talking about in terms of potential energy. Now we talked about tidal range. So this is, I'll come to the tidal range. This is one place in Gujarat known as Gulf of Khambat, where the tidal range is almost like 11 meters in the northernmost point of this place. At this place where near the Narmada, the tidal range is almost like 6 meters. So you have 6 meter head every 6 hours. Every 6 hours you get 6 meters high, and then another 6 hours it becomes almost like low water. So every in a 24 hours you have two high tides and then two low tides. So you have almost like two cycles. So you'll have turbines running almost like 24 hours when you have this kind of tidal basins. Unfortunately, this project is shelved. There is no tidal basin in the Gulf of Khambat right now. But similar one was discussed in Gulf of Kutch in Gujarat again, as well as in Sundarbans. But this is not going to happen in India in the recent, that from based on what I understand. So when you look at this in the barrage, this is like obstruction or where the water goes in and comes in. So the water area behind it, that's the area which defines how much water can be stored. Okay, that multiplied by the tidal range will give us the tidal prism. And then the height of the tide coming in and going in out, that's the tidal range. So we need to know the tidal range, the tidal prism, and the inlet cross section. So if you know these three, we will be able to assess how much power can be generated by using this kind of tidal basins. So way back in, I think 7 years ago, we started our and then looked at different, sorry, I thought I'll come back to that. So when we have a larger area of basin and high tidal prism and a wide width, then that gives us much larger energy. So we have done some exercise for the west coast and east coast. One of my PhD students has done this, and we have identified number of inlets along this both the east and west coast, which I'll show a little later. So by looking at the area, there is a basin area more than 15 kilometers square, and then tidal prism more than 10 to the power 7 meter cube, and then throat width of more than 200 meters. So we have lots of energy potential available. So if you look at this, total we have more than 34 gigawatts of energy. And this is all theoretical again. So when you go into the practical parts, it can even become 50% or even 30% of this. So I mentioned about tidal barrage basin, which is based on potential energy, whereas this is on tidal stream. I said it's based on uh, is on flow of the water. So tidal stream is basically the flow of water through the oceans caused by the flooding and ebbing of the tide. So it's basically like river discharge or river flow, but it is not because of the water coming from the upstream, but because of the tide. If you look at the high areas for the tidal resources, we have many places around the globe. In India, we have Gujarat, which is Gulf of Kutch and Gulf of Kambat. Then we have Sundarbans here. And there is the area potential between the east and west coast of the Sri Lankan, but we are not looking at this place mostly. But more focus is given to the Gulf of Kambat, Gulf of Kutch, and Sundarbans. So since we are talking about the tides, this is one picture which shows that why Gujarat and Sundarbans has got a potential. If you look at the ranges, change in the tidal range, the red areas in Gujarat, you can see the red ones is almost like 10 to 12 meter tidal range is there. If you look at the Sundarbans, even though we have 4 to 6 meters, but there is a lot amount of flow and the constricted flow is there. So we will get very good potential for tidal energy that's based on potential energy. Again, same in depicting in a different one, this study by IIT Madras that they come out with different locations. What are the different types of power available? This again is based on modeling, nothing on measurements. Gujarat, how much is the tidal power and how much is the wave power? Maharashtra, different location, different states, they have put it up. So when you say tidal stream, this is one animation I have just simulated for your purpose that whenever tide is high tide is coming and then water is going in, you can clearly see the arrows that shows the flow pattern into the river. The left hand side is the ocean and the right hand side is the river. You can see that there is flow into the river as well as going out of the river. So this is a continuous phenomena, even though there will be a short gap wherein the tide changes from high tide to low tide. Uh, but then if you look at the currents, mostly we'll be able to concentrate more or make them more um, faster by doing some kind of mechanisms and then use this continuous flow or tidal stream in kinetic power, we can get more energy out of it. This is the basic idea with which I thought I'll give the presentation. So I was mentioning in the Europe, you have flows, tidal stream flows more than 3 to 4 meters per second. So this is in UK or Scotland where you have, you can see this pile-like structure. This is what you see on top of the surface. You will not see the below that there is a turbine running and then that is creating or giving energy. So this is a animation or a cartoon on the right hand side wherein the turbine is below which is rotating because of the currents. And then the top surface, you will see only this much, just like if you put any obstruction in the river flow, you will see only the top hydraulic jumps behind it. So this is the size of the structures we can look at in one of the tidal turbines. This is a 1 megawatt tidal energy turbine again in the North Sea.
Jaikumar sir. Dear participants, due to some technical issues, sir will join again.
Can anyone tell where I lost my connection?
Hello, sir.
Yeah, because I suddenly lost connection. I wanted to know whether on this slide.
Yes, sir.
Okay. So I was asking on which slide did we lose connection on this while talking about this or previously
Sir, previous slide, sir.
on this?
Yes. Hello, sir.
Yeah, this one or the
Yes,
previous
sir.
one?
Yes, sir. Yes, sir. Tidal
On
energy.
this.
Yes, sir.
Okay, sorry about that because I said again I'm not in my office and then I'm using a hotel internet very poor. Sorry about
No
that.
issue.
So this is about a study done by IIT Madras on different states. What is the tidal energy and what is the amount of wave energy available? So we discussed that when we talk about stream potential or stream wise, we need to know whether there will be flow. So we have just showed one animation of a tidal influenced river. This is river Zuari, close to our place where we are living in Goa. So whenever the tide goes from low tide to high tide, the water comes in. When the water comes in at the constricted places where we can see this is Zuari Bridge, you'll have a higher current, which is most of us civil engineers, we are well aware that um, the energy, what you call, cannot be converted. It can only convert, it cannot be created, not destroyed, right? You can only change from one to other one. That is one. Then another one is A1 V1 is equal to A2 V2. That's a continuity. So we have the same amount of flow coming in, and when it gets constricted, we have a higher velocity. So these are the places where we target to have a more tidal stream energy potential. Okay, so this kind of simulations we use. Then I was talking about this, which I think you are. So when you talk about tidal stream and then the river flow, I mentioned in the Europe we have velocities more than 2 to 3 meters or more than that. On the surface, we will see only this kind of bubbles, which is because of the flow and obstruction because of the vertical structure. But below that, we have turbines running in, so which we don't normally see. So this is where the aesthetics comes in, that when you talk about tidal stream energy devices, they are not obstruction or to the eye. So though it is obstruction to the fishermen or fishing vessels, but then we will not see that there is a lot of equipment below that. This is another tidal energy device, which is Alstom known as. This is by Denmark or Danish people, which is about 1 megawatt capacity. Like this, there are many which have been tested in the European waters. So since we have flowing water because of the tide, and once we put a turbine, the turbine rotates. So there is no end for different thoughts on how what kind of mechanism we can use for fixing or putting the tidal turbines. So this is another research area where we are working on. Basically, on first is assessment of how much is the tidal stream energy available in the Indian waters, and then what kind of turbines can come in if there is a low flow, how the turbine should be, what kind of characteristics it is, and then there are many other things in terms of materials which we are not testing, which we are not talking about. Marine biofouling is there. So these are different aspects which people can look at. This is another turbine, open hydro 250 kilowatts one. The turbine actually goes down because it's on piles. It can be lowered down, and then when operations cannot be done or when unfavorable conditions are there, it can be lifted up. So this is another type of turbines which is already in place 1 decade ago. So we have done this exercise of looking at how many tidal inlets are there around the Indian coast. So way back in 2014, we have done this exercise, and then we found that if we have a throat width or inlet width of more than 5 meters, we have more than 470 inlets, 252 on east coast and 219 on the west coast. Whether all are influenced by tide? Yes. Whether all can be used as a tidal inlet? No. Because there are what is known as inlet classifications. Then we need to see whether they are tidal dominant or river dominant or wave dominant or mixed energy. So this kind of exercise we have done. And then we have also done some exercise on if we use this as a tidal barrage, how much energy will be available. I think if you remember one of the slides I showed, on the west coast, we have more than 30 or 40 gigawatts of energy potential if you use as a tidal barrage. So this is another area where we are more interested in looking at different types of energy devices which can be put in the tidal inlets. There is one paper which we have presented 10 years ago on the tidal stream potential at rivers, along with IIT Mumbai colleagues. So I've done a lot of modeling simulations for this region. This is Goa. This is where our office is near Donapola. This is river is Zuari River. This river is Mondovi River. So we are blessed with two rivers, very vicinity, close vicinity. This is where I showed in the previous simulation the restriction. The model simulation was from this cross section up to this. Sorry. So this we have simulated using tidal we by giving the tides here. When you have high tide, water goes in. When you get the low tide, the water goes out. So this is what is happening. And this by doing these simulations, we will know at what locations how much flow will be available. So if that much flow is available, what kind of energy it can generate. So this is where our expertise comes in. So these two locations in River Mandovi just show how the current pattern looks like, point 1 and point 2. If you look at this point 1 and point 2, the black one is the measured currents. When you say measured currents, we have put current meters, not the rotor ones, but what is known as Doppler current meters. And then we have deployed there for enough time, about a week or two. And then what we can see is that whenever the tide changes from high to low or low to high, there is a flow increase. So in Mandavi river, we can see that current speeds are on an average about 30 centimeter per second or 0.3 to 0.4 meter per second. Whereas in the Europe, we are talking about 3 to 4 meter per second. So it's hardly 1/10 of the energy availability. So. And at the second location, we have slightly higher velocities. Slightly high, no, similar velocities. So these are only at two locations. What about these are many constrictions available. So how much is the velocities at that place? So we will not know unless we measure it. So other way of looking at is we simulate the entire area by giving the tides, winds, waves, and then match the simulated measure with the measurements, and then say, okay, whether the model is performing well or not. From based on that, we will be able to generate a map of how much energy is available entire region. So this is current direction. Every 6 hours we have going in and going out. If you look at the directions, it's in the opposite. That is, this 100 degrees means if you add 180 degrees, it's opposite direction about 280. So you can see the variation in the current direction. So we do, as I'm mentioning, we can use these measurements to validate the models. So we have various numerical models like Delft 3D, Mike 21, Telemac. These are there which we use regularly in our institute for many projects. So we have set up different models for different rivers. And then this one typical one, I want to just show this. This is the Mandavi River. What goes into the modeling is the bathymetry, bathymetry is the water depth, similar to the topography. We need to know the tidal levels. We need to have the wave and wind areas, wind fields along these locations. Once we have this, then we will get the tides at different locations and also the flow field, that is the currents. So this is a typical mesh we make for the areas. This is a Mandovi River, which we have seen on Google Earth in the previous slides. We go into very fine mesh to account for the piles of the bridge structures. So that is also locations where we can have high velocities, because when you have bridge structures, around the bridge structures, there will be constricted flow also. Even the water depths may be shallow and then deep again. So we can have regions. So this is an enlarged view of showing the different pile structures which are placed in the model. So once we have that for different, this is for at a particular time step of 10, 9, 22 hours, somewhere here. This is the line you can see. This is at almost like going from low tide to high tide. You can see the flow going in. That is when the tide starts in. You can see the concentration of the, or if you look at the length of the length of the arrow says how, what is the magnitude. Okay, more arrows means we have more number of mesh there. Doesn't mean that more energy, right? So you should be very careful when you see thick line. This doesn't mean it's more energy. It is like more number of arrows are there. So if you zoom in, then we will know how much is the magnitude over there. So if you see this, we have little more velocities at this place and then at this place and this place. So there are potential areas. If you, this is again when the water is going up, that is the ebb tide. So there again we'll see at this location, this and then this location, you have a larger flow. So like this, if you do statistical analysis, we'll know which locations we can get the velocities. So we did some preliminary academic exercise. I will say that without considering the river modeling, if my flow velocity is zero point 0.1 meters to 1 meter per second, and considering the energy like power for half rho a and then a velocity cube. So if I look at for different velocities, I have different energy per second. So if I use about 0.1 meter per second, that's the lowest one, I get only half a watt per meter square. So this is assuming that the turbine is perpendicular to the flow. And then if you consider the turbine efficiency, because we cannot simply theoretically we can use it, most of the turbine efficiency anywhere between 0.1 to 0.35. So if you use that, we have much lower energies available at lower velocities. So if I can increase the velocities, let us say up to half meter per second or even 1 meter per second, we have some reliable or some usable energy possibility is there. So is there any mechanism by which we can increase the flows for the given for the same tidal conditions? And right now we are getting about, let's say 0.2 meter per second or 0.3 meter per second. Can we increase it to 0.5 or 1? So that's the entire thought about it. So before jumping into that, suppose if I get, let's say 1 meter per second, and I take a efficiency of only 0.1. So I have 51 watts per. So if I increase the number of turbines, yes, well, it may be useful, because as per the World Bank data, we need at least 0.21 kilowatt per second per capita power, right? So we have a potential for using this kind of tidal stream turbines where we don't have river discharge, but we have tidal discharge. So this is another exercise I did recently, just for the sake of this presentation, that I took the southern part of the river, that is the Zuari River, and simulated this is a bathymetry used there, and simulated the flow conditions. So what I did is that, okay, to enhance the currents, can I allow the flow to go through a constriction? Okay, that's the first step. And then by allowing the flow through the constriction and by making this shallow, basically again, continuity equation, by making this shallow, can the flow increase? Theoretically, it should increase. But is it true in terms of when you talk in terms of hydrodynamics and then substructure fluid structure interaction and all these things. So did some exercise by making in between the let us say training walls as a shallow water. Otherwise, the green is 5 meter depth. Here it is like 2 meters. Other place it is like 1 meter. So exercise is done. Then what we see is that the orange line, that's the general one without any change in the bathymetry. We get speeds of about only 0.25 meter per second. But by enhancing or by lowering the water depths to 1 meter, so we have almost like a percentage of point from 0.25 to zero point 0.4. So definitely the theory, what is correct, can be replicated in the practice by using this kind of energy enhancing methods. So this is one small exercise. People have been working on weirs and culverts for long. Can that techniques or can that methods or concepts be used in this kind of energy enhancing thing? This is where another research area which is open, which will be happy to work with faculty or students, PhD students working on this. So I'm coming almost close to my talk, and then this is just I said, okay, we have done the startle index classification, and then based on that, we have also done some kind of a tidal stream energy. So we have some studies done in Sundarbans also, along with the University of Edinburgh, IIT Kharagpur, and then there the speeds, current speeds are much higher compared to Mandavi what I showed. They have about like 2 meter per second. So this is another potential area where they have worked out. We have worked out that it is we can have flow turbines in Sundarbans. Each place has got its own problems, but then if people can work on low flow turbines, then we have much larger energy potential, almost all the tidal inlets along the Indian coast. These are some of our publications and invited talks on this particular aspect of ocean energy. One thesis also is done on tidal energy potential estimation impacts of hydrodynamics around tidal power systems. So by one of my student who is also a faculty in Bangalore right now. So with this, I come to end of my presentation. I sincerely thank again LBCE for giving me this opportunity and to the administration for allowing LBCE faculty to take up this FDP program. And thank you very much. And I am open now for any kind of questions, discussions. I am not an expert. I will try to answer as much as possible. But pardon me if I am unable to answer as per your satisfaction. Thank you.
Thank you, Dr. Jaikumar sir, for your exceptional lecture on renewable energy opportunities in coastal regions. Your research perspectives on tidal energy applications were truly eye-opening. We are grateful for the time and effort you took to share your expertise and perspectives with us. Despite your health challenges, I am sure the participants have gained valuable knowledge and inspiration from your session. Now we'll proceed to the interactive question and answer session. Participants who wish to ask questions can ask or they can post their queries in the chat box. Participants can post their questions in the chat box.
Yeah, thank you. Thank you, Mr. Ji Satyaprabha Prabhakaran for giving positive feedback. But I'll be happy if, see, any question is a question. Don't think it is a silly one or something. Uh, Please don't think like that. Think like a student, though you're all faculty members, I know. And then please, so is there any code available? Okay, you are the guys who knows much about codes. Please have a look and then let me know. Otherwise, as of now, in BIS, there is no code for the ocean energy, but I am on board with BIS also in electrotechnical division, wherein we are looking at marine energy conversion devices or techniques as we are trying to implement the International Energy Commission or Conventions IEC TS technical this one that will come out as BIS codes for all these different energy systems for India. It's already some have been accepted, some terminologies have been accepted, and then some methodologies are going on right now. Um, Kailas Patilji is asking which source of renewable energy is underutilized. Renewable energy. Every renewable energy is underutilized right now. The reason is the efficiency of the turbines. If you talk about turbines, if you talk about solar, you know very well, it's only 30 to 40%, I think, to my knowledge. Wind again is less. We have about 40, 50% CPE of the turbines. So everything is underutilized. So there is a lot of research needed and lot of work needed for making these more efficient. So another question by Satyanarayan Murthy garu, we mentioned about potential of power generation in run of Kutch, run of, sorry, it's not run of Kutch, it's Gulf of Kutch, Gulf of Kambat, Sundarbans. Other areas, see, vast seashore is there, then why can't we have it? I'll try to bring you or take you back into the tidal ranges. Okay, just like we have dam heights, the larger the dam height, the larger the power. Likewise, the larger the tidal range, the larger the power. Okay. So in the Gulf of Kutch, Gulf of Kambat and Sundarbans, the tidal ranges are large. That is the reason these three places have been studied much better than other places. But that is where our interest came in, that we have a lot of other shores, potential areas are there. Why can't we use that? So we cannot close all the tidal inlets, because by closing the tidal inlets, we will run into problems with eutrophication and allowing the fishermen or navigation systems. So instead of blocking it, we can have the turbines for kinetic energy conversion. So that is Satyan Murthy's question. Does climate change, Satyaprabha is asking, does climate change impact energy production? Climate change impacts other processes, physical processes. It is considered that climate change will, we have a PhD student recently submitted on impact of climate change on the waves. We have seen that there is an increase in the wave heights, which means that there will be increase in energy, but also we have seen that there is increase in the winds, which means energy will be more, offshore wind energy will be more. Sea level rise is going to increase. So that means tidal stream energy also will increase. So definitely climate change is going to help us in terms of increased energies. However, the hazards also are going to, marine hazards are also going to increase. So we are both in terms of energy, we get more, but in terms of protecting the infrastructure also, we need to do more under the climate change.
Jaykumar, good evening.
Good evening,
Yeah.
Nayar.
Your session is very informative and it is new to most of the faculty. My question is, I think the turbines has to place perpendicular to the flow, but in the sea, the flow may not be constantly in the same direction. What will happen? What is
Okay, so
sometimes it
if you look
may.
at oscillating water column, OWC, that turbine is unidirectional, irrespective of whether air is going up or down.
Okay.
So the turbine blades are designed such that irrespective of the flow direction, the turbine will move in the same direction.
Okay, okay. I think the manufacturing in the
Yes,
it
it's
will take care of.
putting the angle of the fin, those things are already, I think, well established, because OWC they already is tested and then it's already there in place. So similar kind of things will be used. There is a question on OTEC. We have two cycle systems, open and closed. Which one is more effective to produce energy? I confess I am not a OTEC person, but then NIOT, if you go to NIOT site, a National Ocean Technology or anywhere in the internet, you will have which one is the better efficient. But right now, I think we have a closed cycle system which is being planned in Lakshadweep. And similar to that only, this LTTD, that is a low thermal desalination plants are being worked in Lakshadweep Islands.
Participants, any more questions? You can post in chat box here.
Did I miss any question? No.
No, sir. No, sir. We have answered all the
Okay.
questions.
Yeah, one question to everyone. How many of you are willing to work on this topic? Yeah, you can please email to my email. I think mine is very easy to remember. My JAY is the J .nio @gov.in or csrareas.in. So you can get my email address on the net. Thank you everyone. Yeah.
Thank you, sir.
On behalf of the organizing team and all participants, we extend our heartfelt thanks to you, sir, once again for this informative and thought-provoking presentation, sir.
Thank you very much. Have a good night.
Thank you, sir. With this, we conclude today's Day 4 session of our ACT ATAL Faculty Development Program. We sincerely thank our esteemed resource persons and all participants for their active involvement throughout the day. Participants are kindly requested to fill out the feedback forms for today's session. The ATAL FDP will resume tomorrow with Day 5 session, featuring more enriching lectures and discussions. Thank you all and have a wonderful evening.